Good morning, YouTube audience. I just want to shoot this video here of a PV install. This is in north central West Virginia. I've been kind of researching this for several months. I've gotten started on the project. I'm waiting right now currently for a quote on the racking and panels and basically the meat and potatoes of the whole system. In the last couple months I've installed what you see here, which is all of the pre-wiring for the system. Grounded it, just tying up a few loose ends here. Just thought I'd shoot this video while it's still open so you could see my setup. I've watched just about every YouTube video out there, and some of them were helpful for what I was trying to do. Some of them weren't. Many of them weren't. But I just used the best of whatever I could find to really design this system. And like I said, I'm waiting on racks and panels, but I do have my conduit up to the roof where I'm just going to go from there. I've laid out the roof already, put some marks on it with, as far as where the racking's going to go, found all my rafters. Just basically did a layout up there on how I wanted the arrays to be oriented. So that's all taken care of, and so a lot of the preliminary planning and stuff is done. Of course, obviously, if I've done this, I've gotten permission from my utility to go ahead and install the system. I'll have to have it inspected by a licensed electrician. By the way, I am not a licensed electrician, so just so you know that. So I don't endorse anything here as being, a professionally endorsed, but I've tried to follow the NEC code 690. Article 690 is for solar installation, and then all the other general guidelines for just electrical wiring and installation. But what I have here is the utility company requires an AC disconnect. So that AC disconnect right there, it came, I got that off of eBay. Actually, it's a 60 amp. It is a Siemens. You can see I've put all the, labeled everything with, for solar, so the power company would know. But it's right next to the utility meter, the consumer meter. So in case they ever had to shut it down, it's got a throw switch there. But basically, it's just all wired up in there, grounded, and that's so that's gonna come down, and it goes right in here. That goes into the house to the main panel. So basically, this is like the combiner sub-panel box here. So it's going to come down off the roof from the solar panels. It's going to come through this combiner box here, and this is a square D box. And it's going to come through here. And I've got the breakers. I just don't have the wiring in there yet. I'm going to put them in. Thought I'd shoot the video here before I actually ran the wires. I'm going to have 2 branch circuits that are active, and this one right here, I'm just pre-wiring it for a future. In a couple years, I want to put about 16 more panels on the front roof. So I'm going to have 12 panels, and 16 panels. And derating for the size of the panels, I'm doing an Enphase Microinverter install. So I'm going to have 12 microinverters up there. I got 12 275 watt Solar World panels. That's going to be in each. These are the 2 branch circuits. This one's going to be the top, and this is the bottom, and this is going to be the northwesterly facing roof in a couple years. But I derated them. They put out about 32 volts, 12 amps. So they're derated. So I got a 15 amp and a 15 amp breaker, double pole breaker on there, and then these are going to feed into a 50 amp breaker in the main panel. But that's where it comes in here, and then obviously I've got it coming out over here because I wanted a solar generation meter. So I've got it coming out over here, which is going to be. I'll show you this video whenever it's all put back together. But this is a generation meter. Got that off eBay. It was an Elster, ABB Elster. Just a plain old. I didn't want the fancy digital smart meter type stuff. I just wanted just a mechanical meter, just so I could see what I'm generating, so I can keep them honest whenever they read that one. And I'm also going to have monitoring with it too, so I've got 2 ways to tell. This is a physical means, and then I've got the the monitoring that goes over the internet through on the Envoy system to the Enlighten website. So I'll be doing that. But anyway, it comes, like I said, it feeds in here, so I can measure my generation, lifetime generation, and then basically it comes back. It comes into here. Okay, the feeds come down through here. They're not hooked up yet. Okay, into there, and then they come through the meter and then back through, up through to the disconnect, and back down in, and right there into the house. And this is my ground. Of course, you can see right here. I think you can see it. I'm grounded right here, and this comes down, and it comes down to a wherever it's at. I've got a it's buried down here somewhere. There it is. It's coming down to my grounding rod. And actually, I wasn't sure about the distance from the house on that. I'm going to have to check with the electrical inspector on that, see if he doesn't like that. I'm not sure where the original ground GEC is, the ground rod. Right there is the, right there's where it goes in. The panel's down below, and it's like another 3 feet down the ground. It comes out of the main panel and through the blocks. So I'm thinking it might be back here in the corner somewhere of the house, but it's about 6, I think it's close to 6 feet, but I'm not sure exactly where the original one's at. But I drove that one there, but I was kind of thinking maybe I shouldn't have done that. So I ran more wire. There's actually more wire ran clear out to here. I've got it right there in case I need to run another ground rod. If the inspector doesn't like that, I've just kind of got it set up and ready to do that if that's what I need to do. And that will be, I know, 6 feet away. But yeah, I did all that, and see, what else can I tell you right now? Not a lot right now. I'll try to give you more information later. I'll show the stages of putting the Iron Ridge racking and the panels and the Enphase inverters and stuff, and I'll try to tie this all together into a decent video for somebody that's doing an install similar to mine. So. But I'll show you this. I'll show you this put back together here in a minute, so you can see what it looks like put together, and then from there we'll concentrate on the panel installs up top. So we'll talk to you next time then. Thank you. Okay, now I'm down in the garage area. This is outside there. You can see how there, where we were just at moments ago. That's where that combiner sub panel box is, and you can see this black wire right here that runs up. That's where my feed is coming into to the main panel, and this is it. Like I said, this is in the garage. This is down inside. It's kind of tight in here, but it's back in the corner. Okay. Right here, you can see there's the 50 amp. It's a GE box, and you can see I put the 50 amp breaker in there, double pole. Right now I'm running 2 circuits. I'm going to have 2 circuits. They're each going to be 12 amps each, and I showed you the sub panel box outside there. I have 2 15 amp breakers. So I'm going to be running, 15 is 30, and then you've seen I had one that's not in use currently. It's a 20 amp breaker. Now that breaker is for probably within the next year or so. I'm going to put 16 more panels over there. That's why I have a 20 amp breaker out there along with the 2 15s. Currently it's unused, but this system is going to generate no more than a maximum 50. It's circuit protected for 50 amps, but it's going to be no more than around 45 amps or so would be the most that this system could produce. That's the absolute maximum it could ever produce in the ideal conditions, which that's never going to happen. But I just thought I'd show you the breakers I used here. I may end up taking this breaker out for now because I got a 50 amp in there, but I'm gonna I decided not to put the 16 on. I couldn't afford it right now, so I'm going to do that later, but I got it pre-wired for it. So I'll take that out and probably put a 30 amp breaker in there for now and just keep that 50 whenever I install the 16 on the front, on the front side roof to catch all of my afternoon and evening sun up here on the hill. Then I'll put the 50 amp back in it whenever it's actually, when it's actually at maximum capacity with all of the panels that I intend to install on it in the future. So just wanted to show you that for now, and we'll go back up top. There's one more thing I want to show you back out there. I want to retrace that circuit again, just in case I went a little too fast with that, so you can see the circuit path and how everything comes in. So we'll do that now. Okay, one more time. I wanted to come back outside. I come out of the garage there, down inside. I want to come back out here. I want to trace this circuit path one more time, just to make sure that I didn't go too fast with it. Okay, we've got, right up there, it's going to come in. I'm going to have two branch circuits, okay? There's going to be 12 amps coming into each breaker, 2 hots coming in, and then the grounds are going to come down and hook onto the grounding bus bar there. Okay, so I'm going to have 4 hot wires coming in, 2 for each circuit. Okay, and they're going to hook up here. Okay, on the bottom of my 2 double pole 15s. So that's where it's coming in from the J boxes up top on the roof. I'm going to have 2 J boxes. Each circuit is going to be tied into the J box, and then they're both going to home run down to here, and then they're going to tie in here. Okay. Okay, these breakers are hooked on here to the sub panel box, obviously, and then of course you got your neutral. Now the neutral, I'm sorry, you got the 2 hots, and you got the neutrals coming down here too. Okay, and the neutrals from up top. Okay, you got 2 hots on each circuit, 1 neutral on each circuit. 2 neutrals will hook in here, 4 hots, 2 and 2 are going to hook in here. Okay. Now this neutral, the main neutral, is running right straight back into the main panel. Okay, that's important. This right here, that bonds the neutral and the ground, neutral to ground. You don't want to do that in here. It's bonded, I think by code it has to be bonded back at your main panel. It's not bonded here, so make sure that screw that comes with this box, you leave that out. Okay, so this is run, the neutral is running right straight back. Okay. Okay, now the wires coming out of here, you've got, here's your hot, here's your L1 and your L2. Okay, line 1 and line 2. Okay, red on the right, and then your black. Okay, black comes right here. Right there's the black, and there's the red. Okay, they come out of here, and they go over, and then they come up. They come over and they come up on the line side. This is the line inside for the meter. Okay, they come on the line inside, goes through the meter, and then they come out on the load side. Okay, and then the wires run back through on the load side, and then they run all the way up to the safety disconnect. Okay, and the safety disconnect, the top, that's the line side. So it's coming from the load side of the meter up here to the top side. That's the line side. And I think in my my West Virginia Public Service Commission, I think it's called the Net Rider. It tells you about that. And I think the power company, First Energy Company, Mon Power, they've got that information on their website that tells you it has to come in the line side. Just so you know that. I don't want to confuse you or confuse myself. But right there's the line side. It has to come in the line side, obviously. For the disconnect to work right, you have to plug it in the right side, obviously. And then the bottom here, these 2 on the bottom, it's your load side. That comes back out, and it comes down, back down, and then that is what goes right back in, right back into the main panel. Okay, and then from there it hooks onto that breaker I just showed you that I had installed in the main panel. It goes back in. Now, of course, I got the grounds. You know, these boxes, the grounds are right here. You know, the boxes are, these are your EGC, your equipment ground conductors. Okay, this box is grounded. This box is grounded. And you'll see there's two of them. I ran one up, and then one goes back in the wiring. It was just in this cable that I bought that had the number 6 conductors in it. And I don't know if I really had to run that back to the main panel. I did, although right here's the other one that grounds that box up there. It comes back, it comes out, and it's grounded right here. This whole PV system has its own separate ground rod. And I believe that's part of the code as well, that it has to have a separate ground rod besides the one that the main house has. But I did, like I said, if this is wrong, the inspector will tell me that I can't have that ground wire running clear back to the main panel. I don't think I'm violating code. I tried to be a little bit liberal on everything as far as wire sizes and everything. I mean, I'm going to run 2 grounds if I have to, 2 ground rods. But these are number 6 wires. Obviously, these boxes here, they're made for like number 6 and above, number 6 and bigger, and as well as this, it's like number 6 and bigger. You really shouldn't be trying to stick, 12 gauge, 10 gauge, or even 8 gauge in there. Really it needs to be number 6. I mean, there's reasons for that. It's obviously going to run. The whole system's going to, it's going to run more, more bigger the better, basically. But I don't have a long run. I've only got about maybe 15-foot run up the conduit where it's going to hook up to the J boxes. So I don't have a long run. I don't need to worry about voltage drop or anything like that. But yeah, I just wanted to tell you that these are 6 gauge wires. The grounding wires, these are 10 gauge. And when I'm going to have 10 gauge wires running in here, the PV cables, it's called N-gauge cable. It's actually 12 gauge wires, but I'm picking up in the J boxes up top with 10 gauge wire. I'm going to put 10 gauge wire in it. Just like I said, I'm going liberal with everything, but I'm running 10 gauge wires down to here. I'm even running, I don't know that I have to run separate ground wires, but I'm going to run each circuit. I'm just going to run a dedicated ground wire down and hook it in here. I got plenty of room on my bus bar, so I'm just going to hook. There's going to be like 3 of them ran down, really. 1, 2, and 1 for the future. It's going to be capped off up top. Those are going to be 10 gauge wire, and then of course I'll ground the racks up there. The inverters are ungrounded. It's the new style where you don't have to run all that ground wire up there and bring it down, tie it in. The only thing I have to do is ground the racks up there, bond the racks together, and then I'll run one down. It's going to be, I think that's 6 gauge wire, 6 gauge bare copper. I'll be running down to here, and then of course this is number 4, the grounding rod conductor. That's number 4. That's your standard size for ground rods. But I'm going to run a number 6 down and tie it in there. So hopefully I've got this thing grounded well against, to guard against lightning strikes and stuff like that. So hopefully that'll be taken care of when it's all said and done. But anyway, that's the circuit path I was just trying to trace out there for you. I might be talking too much, but hopefully you can kind of follow that. Okay, this is everything put back together. As you can see, it's all closed up. This is what everything looks like when it's all back together. There's the breakers. Okay. And then there's the generation meter, which, as I said, was a mechanical meter. It's an Elster, ABB Elster. That's the company I bought it from off of eBay. I think I got that for about, I don't know, 20 bucks maybe? $25, somewhere around there. It wasn't expensive at all. And it's just a nice mechanical meter. It looks like it was refurbished. It was just, calibrated and refurbished. Seems to be like a pretty good meter. It's all zeroed out, ready to go as soon as I turn it on. But anyway, that's the total generation meter, your solar generation meter that I'm going to use to make sure they're crediting me like they're supposed to. And of course, like I said, here's this is the sub panel combiner box here. And of course, see, I put all the stickers and stuff on just so, you know, anybody comes up here, the meter guys or power company people, anybody, they're going to see all the stickers and know something's going on here. You know, solar in use, blah, 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 what it is. You know, it's a 240 volt system, obviously, because it's microinverters. It converts the DC to AC right at the source, at the panel. And then 50 amps would be the maximum this system could ever generate. So give them all the right information on here that they need to know. But again, that's just wanted to show it to you all closed up, and you know what I actually have ready for panels here. So we'll proceed from here with the actual install of the hardware up on the roof. Okay, here we are outside. Once again, clear back up on the bank here so you can see where this solar PV system is going to be installed. Once again, there in the foreground down low, you can see where we were just at the where I was going over the wiring and the tie-in and the meters and everything right there on the side of the house. Now we're up top here, and I'm just kind of showing you a view from clear up in the back, so when we get up on the roof you can see what we're doing here and what the layout of the whole house and the property and everything is. We're up kind of on a hill. You can see off in the distance out there, maybe you can see it. See, that's the highway, that's the interstate. So we're up on the hill pretty good. This roof line here is about, I think it's about 160 degrees southeast. I have a 4-on-12 roof pitch, which is about 18 to 20 degrees. And with that tilt, the latitude we're at here should be about 39 to 40 degrees is the optimum tilt due south to catch, you know, optimal rays from the sun. But I'm not exactly due south. I'm about 15 to 20 degrees from being due south. So actually I have a better orientation with the roof lying a little bit flatter than 40 degrees, being that it's around 20. Because I'm south-southeast facing, that is the more desirable orientation of the roof line. If you do not have a 40-degree roof pitch, you know, facing around 160-65 degrees is a pretty good place for your pretty good orientation for your home and your roof to be in. And the reason for that is, if you remember, I was talking about putting in 16 panels on that opposite roof over there on the opposite side, and that is actually a northwesterly. That's a east by northwest facing roof right there. So what happens is when the sun gets to be about 11 o'clock, this is summertime, but when it gets to be about 11 a.m., I'm getting sun on that other roof. So from 11 clear to like dusk, I mean 8 o'clock, I'm getting, well, maybe 7. Depends on when the sun goes down that horizon over there. I actually am getting a lot of sun on that opposite roof over there. If I had a 40-degree facing roof pitch, I wouldn't get that kind of sun on that roof. So being that my roof is a little flatter, it's actually desirable, and that's why I plan to install another 16 panels on that opposite roof, because it's pretty much going to take up this whole side right here. Above that solar pool heater there, that's going to be all the way down with solar panels, except for a break right there with that one vent pipe and that one that skylight. I'm going to have to make 2 breaks right there in the branch circuits. I'll break them right there, but there'll be 12 panels on each row. There's going to be 9 on this side of the skylight, 3 on the other side. Then there's going to be 6 on this side of that vent, and 6 on the other side. So that's what we're getting ready to do here. So I thought I'd just show you this, so you could kind of get an idea of what we're doing here. Next thing we'll be doing is starting to lay out the racks and installing racks. Okay, I'm waiting currently on the rest of the materials to get here from New York. They should be, I thought they were going to be here today, but probably Monday I'll have the panels, inverters, all the rest of the hardware, racking, everything. But this is just kind of what I've been doing while I'm waiting. You can see all these PVC conduit laying here. I just made a, these are some of the, this is just the rough connections I'm going to need, but I made up bought a J-box, and I had to drill it and just basically make a custom box. You can see that is going to be, this is going to be the main J-box right here. When it comes off the roof, you'll see it whenever I get it up. You'll see it all tied together, but this is just some preliminary stuff here. But that right there, that's where it's going to go down through the roof, tie in with the combiner box, the sub panel, come on into the house. But this one right here is going to go all the way across the span of the house. I'm going to pre-wire for the lower panels that I'm going to install, hopefully in the next year or two on the pergola, back to pergola. So I'm just doing some pre-wiring. That's what this was all about. But this one right here, this one is actually for the top circuit, branch circuit, and this big box is actually where the bottom branch circuit ties in underneath right there. That's where it's going to come in. And of course this is going to be pre-wiring for future. And this right here, you can probably see that is actually where the number 6 continuous ground is going to come in, and it's going to run all the way back down to the sub panel box into my GEC, my ground electrode rod. My ground electrode conductor is what this is right here, and it's going to run to the grounding rod, which you kind of see laying right here. I've already got one driven out there, but that's an extra one I might do something else with. But this right here, this is actually, right there is the other J box, and right there's where the other wire from the top array is going to go in. And that's the first branch circuit on the top branch circuit, and then it'll tie into the bottom branch circuit, and then it'll go back to the home run, and then this will eventually be another one that'll go back to the home run eventually. But that's what this is right here. Just going over that real quick. You can see right here on the end of this one, I just capped it off. I actually got a J box here that had 2 glue-in fittings, and I capped the top one because I left an option open. You know, this is going to be the top of the roof. On the front side of the roof, that's how I was originally going to expand the system, but I think I've changed my mind. I'm going to cover the pergola and basically have a solar roof on top of the pergola. But if I do put something on the other side of the roof, this will allow me the option in the future to where I'm gonna actually have it pre-wired too. I have it pre-wired there too. If I want to add something else to it, I'll just have them capped off in there, and then I can just add the panels over there and just tie them in right here. So it'll make it. I'm just trying to think about things I can do in the future. So that's where we're at now. Show you a couple things up here, a couple more materials I got. Last little bit of materials, hopefully I'll have to buy. 10 gauge wire, ground, neutral, L1 black, L2 red. That's 100 feet should do what I need for all the pre-wiring and the existing panels I'm putting down. It's a disconnect tool. A couple of all-weather caps, because I'm going to be running, I'll show you this later, but I'm going to be running an extra drop that's going to be unused because I have to split a vent pipe and I have to split a skylight. So I'm going to be covering them with these. This right here, that's a disconnect tool from the N-gauge cable. If you need to break the cable, or if you need to unplug it, that's what that's for. It'll go in there and it'll unplug. You can put a cover on it. You can put these covers on, or you can put the regular connectors off of the M250s, the microinverters, The red caps are just dust covers, but if you need to leave one out, you know, if you have to leave one out of the drop, out of the circuit, you know, you'd take this off. Okay, and then you have this Enphase cap, and that would go right in there. You heard it click in. These little tabs down in there, it clicks in, it locks. You actually can't take it back off. Well, you could if you, but they make this nice handy little tool here, about $7. You just stick that in there, and it spreads them apart. And then, let's see if I can do this one-handed. And then it pulls it. You can pull it right off. Hang on a second. Need two hands. Okay. Well, I just dropped it clear down in the box. You get the idea. That's what this does. So, that's all the engaged cable in there. And a few other things. I got you know, some hangers. And here's my, it's going to be my ground rod, number 6. That's going to tie it in. It's going to come all the way down to the combiner box out there. And this is going to go to ground, but this is going to be basically the continuous ground that comes off the roof for lightning protection and whatnot. Some of these other odds and ends, just some things, you know, there's some self-tapping screws, just wire nuts, a few brackets, but just basically that's all I got here. This right here is the Enphase Envoy. I've actually already signed up for an account. I've logged it on. I put the wireless adapter in it, just checked that everything worked out on it, and I could, you know, sync up to it with the router, and it did. So that thing's ready to go. And these are the end caps. It's going to go on the racking that's coming. But that's it for now. So we'll pick up later. Hopefully next time we pick up, I'll be putting some racks on the roof. See you later. Okay, here we are on the back deck. I've got 2 sets of 24 modules. The shipment came yesterday, so here's the modules we're going to be putting up there on the roof. And these are the monocrystalline Solar World SW275. Hi, Laurels. And 275 watts monocrystalline. These are some of the best panels money can buy right here at the moment. They are about 66 by 39, so about 5'6" by 3'3", and there's 24 here, and then we got 24 more of them over here, or I'm sorry, 12 over there and 12 of them over here. Kept them covered because I didn't want too much sun on them. I mean, it's not going to hurt anything, but I just didn't want them sitting down here producing a bunch of energy, a bunch of electric. So we're going to be putting these up on the roof. I got some hardware downstairs I'm going to show you that came in. The inverters and stuff come in. I unloaded them in the garage. I unloaded these. I carried these around the back, but all of them's going to be going up there here shortly. I got my marks and everything up on the roof. So I'm going to start snapping some chalk lines and laying out the racking, and that's going to be the first thing we do. Putting the feet in, securing the feet down, the flash footings, and the standoffs on the roof, and then the racking goes on that. Okay, here's the rest of it. It's kind of dark in here, but got some racks up here. There's the racking, the Unirack XRLs racks, aluminum racks. I'm only going to have to make 2 cuts. The rest of it's sized. You know, they come in 12 footers, 14, 16. I think they even come in 18 footers. But my particular configuration called for this, and I've got to cut 2 feet off of 2 of those 12 footers, and that's it. So I won't have to do any more cutting other than that. Then I got the hardware and everything here. You got all the flash footings, the the cable management clips. Now, I was a little bit disappointed. I thought these were going to be stainless steel clips. The Enphase ones are. If you get the Enphase ones, they are. These are the Iron Ridge. So the Iron Ridge ones, they're a plastic kind of a clip, polycarbonate something or other here. I mean, they were cheaper. I mean, I not really, if you price it out. These come in bags of 20. I think the Enphase ones comes in bags of 100, the stainless ones. But these are going to be, you know, you got to look at them for what they are. They're cable clips. They're going to be under the panels. So people use zip ties. I mean, I didn't want to do the zip ties. I thought that it was a little more neat and tidy to use these rather than zip ties. But it's not really a big deal. All this is just all the mid clamps, and these are the Iron Ridge, the grounding mid clamps. They have, you can see it in the bag here, but they have little teeth on them. See the little teeth. Everything's got a UL number on it. It's all got a UL number. So they work like the weeb washers. But these are actually kind of cool. I like these. Probably these are better. I like these better than the weeb washers. And you got, I don't know if you can see it, but you got, maybe you can't see it, but there's little teeth on the bottom of this this hardware here too. So these dig into the panels at the bottom, and then these dig in at the top, and it basically bonds them and grounds them. You got your splice kits here. This is the splicing for the racks. That's how you splice them together. And then I've got end clamps here somewhere. Here's end clamps. I've got them all. I think I got 44 total packs of 44 of the mid clamps, and then I think I got about 16 of the end clamps. And then when you splice the rails, you got these the ground straps to make sure they're bonded. And these are also, like I said, everything here with Iron Ridge stuff is UL approved. So, and I think got a couple of the terminator caps to terminate the trunk cables. Like I said, everything's already been counted out in here, so that's all here. And then that's in this box. It's just and the L feet and all that. The L feet to mount on the racks. And then you got these 3 boxes. I went ahead and bought the quick mounts. I got they make 2 different kinds of flashings. They make the 12 by 12s, and then they make the 12 by 9s. I got the smaller ones. I didn't really need those real big ones. But they come with the hardware, and these were kind of opened. You've got this bag of hardware is to mount the bottom of the flash feet onto the quick mount panels, which these are the quick mount panels here, and these are the flashings. Got like the standoffs on them, and water can't penetrate them. I went with these because these are pretty popular because they swivel, but it's like there's an offset in there that water runs down, and it would have to go up and over to even get in there. But then you got these down in here with rubber seals sealing it off, so you just can't get any water in there. They're pretty easy to mount, and you only got to drill your roof one time and put these these bolts down into them, and you turn them like this so the water sheds off easier. You got these rubber seals here, and like I said, this is the hardware to mount the L feet on top of this flash footing. So and then the rails will go on that. You got these here, and you got a nut, and there's another like a stainless washer with a seal on the back of it here, and that is actually what goes down inside of here and seals. It'll seal down in there first. You lag it down. It seals once, and then after and then you got these that go down in there over top. These go over top of here, and they seal it again. So it's got like 2 seals down there when it's all said and done. And then the flash feet are sitting down on top of that. So these are pretty good mounts. So that's the quick mounts here. I've got 44 of those total. I think I'm only going to need about 42 standoffs, but I got 44 total in case I need a couple more here and there. And then the rest of this stuff, this is just some of the other local purchase stuff. I mean, here's the end caps for the Iron Ridge, and straps for all my conduit and everything over there. I showed that earlier, and there's wire nut number 6 ground to ground all the racks and panels. And then I got 2 boxes of inverters. They come in 12 to a box. Only thing I think I'm going to have to do is I think I got to get some 1/4 stainless bolts, probably 1/4 by 3/4 inches long. Because I didn't see any hardware in these bolts. Usually everything comes with the hardware to mount it and everything, but these didn't for some reason. I think that's a separate little kit, but I'll just get down to Ace Hardware and get some stainless bolts, and no big deal. Those would be the ones that you use to mount these down on the racks. But these are the inverters. There's 2 boxes of 12, and these are the M250 inverters. And I need to drag them all out of here, but you can see these are the M250s. And, so that's what I'm going to be taking up there to mount shortly. But that's pretty much what came yesterday. So next step will be snapping chalk lines and putting down the rails on the roof. Okay, we started this morning installing the flash footings and the standoffs. What I spent the morning doing was I already had marks on the roof where I had laid it out previously. I only got about 3 of them done here today. It's getting a little warm. It's kind of going to chew the shingles up if I work doing this job too much. This is a job you probably want to do later in the evening or earlier in the morning whenever the shingles are cold. So, but what I did was went and snapped chalk lines on all the 4 feet apart on all the roof rafters. I've got the whole top one snapped down the roof there. That's going to be the top rail. Basically, I'm going to get all these down the top, and then I'm just going to check my measurements for the next 3 rails on down. Make sure everything's lined up and square. And most importantly, everything is in the roof rafters. The lag bolts are penetrating roof rafter. That's the most important thing. So you can see how I snap chalk lines down the roof every 4 foot on center. I did that all the way across the roof. I got a few other little marks in there, but all the way across the roof, that's where we're at today. So we'll pick up with it in the next day or 2. And hopefully next time you'll see all of these installed. Okay, we got the racking on now. It is complete. All the racking. Today we're going to run some electrical. Everything today is going to be all electrical. So once we get we're going to be running the trunk lines, probably putting the microinverters down in place. Got a little bit of conduit I need to run out there on the end where the stub's coming up out of the end. And then we'll pull all the wires through the conduits, cap everything off, tie everything in together. Once that's done, the last step is just putting all the panels down. I've already, when I installed the racks, you can see I've already put all of the mid clamps, end clamps, everything's on there. It was pretty slow this week actually putting all this racking on. All I can say about the racking is you got to do it a few times to be good at it. I got better at it towards the end, but it's something that takes a little bit of time. They say measure twice, cut once. Well, this you better measure 3 or 4 times before you cut anything. I actually made a cut. I was originally going to just run this rail clear on across this vent pipe here. I ended up having to split it because when I ordered my racking, I actually forgot to account for that 32 5/16 inches right there for that vent pipe. I accounted for it up here, but for some reason I wasn't thinking. So you got to really be on your toes as far as your mathematics here. I had to move a couple flash footings here. I moved one from there over. I just moved them over 16 inches so I could split them and support the ends of the rails here. But everything's good with it. But one thing I did learn that I never read or saw anywhere, the way to level these. Now, obviously, when you're lining them all up, You know, because these panels, when they lay down, there's only just maybe a half an inch left over on that rail, if that. So across a long span, you know, you gotta be pretty accurate. But once you line them up, once you line everything up, when you level them, you got to level them. I would go from one end to the other end of each section, and I set mine about 5 inches off the roof. So I set one point and then another point, and I did that, you know, on every track wherever it ended. I set them at 5 inches, and then I just went along. There's a couple score marks here in these iron ridge racks. You got a couple score marks that runs clear down. So I just used those as a guide. Held my chalk line on each end, snapped it, and then I could go all the way down through each of the flash footing, each of the standoffs. I could go all the way down through there, and just loosen them up and raise them where they need to be, up or down. And that actually worked really well. I've never seen anybody do that, but it gave a good guideline to do that. And I've actually gotten down and looked at these racks, you know, clear down the row, and I mean, if you look at, I mean, they're pretty straight. They're pretty straight. Of course, there's chalk line snapped where all these flash feet are at. So, but you do have adjustment room on these up or down, however you need to do it. But pretty much, if you stay on the lines, they're pretty straight, and all the way down. I mean, clear down, they're pretty good. So I think they're level. We'll find out when I lay the panels down. But today we're going to get started on electrical, and we'll pick up from there. Well, I didn't get as far yesterday as I really wanted to last time. I thought maybe I would have this wire ran and have the microinverters down. Didn't quite get there, so we're going at it again this morning. But that's what we're doing is we're running wire right now. You can see how I've started this right now. Started running my number 10, L1, L2, black, red, neutral, green is the system ground. And I've started, this is what I'm wiring down here on this end. I ran a conduit all the way clear up to the J box and the end conduit there at the end of that raceway. This is actually pre-wiring for what will eventually be a covered solar pergola. Eventually, about a year or so, we intend to do that. We're going to see where we land with this one first, as far as supplying the energy for the home. See how we land with this one. But yesterday, I put down some wire management. I put down all the wire management clips. This is where all the wiring and everything's going to run down these two center tracks. And I did get the equipment grounds, which is number 6 copper and your ground lugs. Basically, I'm grounding to one. There's 2 branch circuits, a top and a bottom, and each one of those branch circuits is broken in half for this skylight and for that vent pipe. So this is a subarray. This is a subarray of the first branch circuit. Then we got where we're at right here. This is a subarray, or I'm sorry, this is a subarray that we're standing on here, runs out to that vent pipe, and then there's another subarray on the other side. So there's 4 subarrays total of the 2 branch circuits, a top and a bottom with 4 subarrays. So I grounded this subarray, right there grounds this subarray. The wire runs down to here, makes a bend up, then there's another ground lug there. That grounds the top subarray. So then it runs down here so far. This is all going to be underneath the panels. You never even see it. Runs down here, and then there's the 4th and final grounding lug, and it takes it all the way down to the end and goes in the J box. By the way, right here is the overpriced N-gauge cable, is what it's called. This is all the drops. The microinverters have special adapters. They plug into all this. There's 26 drops there. I got 24 microinverters, but where I split it right here, and right there, the wire's going to run on through, and there's going to be one unused drop. I come down here to the other end, we'll show you how I tied in the rest of it. There's that copper ground running all the way down. Continuous ground running all the way down to the service, to the sub panel at the bottom. But I ran it down here, ran it into the J box. Comes into the J box, comes through and goes clear down to the sub panel all the way down there. Or it goes down to the sub panel, which picks up with the number 4 at the ground block, and then it runs right straight to the ground rod down there. So, but this is what I did yesterday. I'm in the process of pulling that wire through. I thought I was going to be able to push it clear through, but I think I got it. I think I got it about 3/4 of the way, and it's just getting too heavy. It won't push anymore, so I'm going to have to pull it the rest of the way. But this is the J box for the lower branch circuit. That's the J box for the upper branch circuit. That one, they'll both just come tie in right here, go right on down. And then this is the pre-wired one that it's unused, but it's going to come in and it's going to go down to the wires I'm pushing in down there at the other end now. So that's how it's going to be. I'm going to have three circuits, two active circuits for this install, and one pre-wired circuit with nothing going to it, just capped off at the end. So we'll pick up later with, hopefully next time we pick up we'll have some microinverters down to show you, and we'll be laying panels, and that's about it. We'll be ready to commission it. Okay, we're in the heat of the day now. You can see that we've got all the microinverters installed now. So we did that. That's what I got done today. I'm going to probably get off the roof now because it's getting really hot, so it's time to take a siesta. Terminator caps. That's those are Enphase terminator caps. That's how you terminate the end of the circuit. So this whole row right there, 12 solar panels, 12 microinverters. Same thing for this one. 12 solar panels, 12 microinverters. Now this subarray splits right here, I told you that earlier. This one keeps on going a little bit, and it splits right here. Then this one up there starts at the skylight, goes all the way down, 9 panels. Other side of this vent, there's 6 panels. Got all the wiring ran clear down to the sub panel. And here's the boxes. I'm getting ready to close these boxes up. That's for the future pergola install there. Here's the one that we're doing right now. Everything ties right in here and goes right on down over to the sub panel down there. And here's the boxes. I'm going to tie them in and close them up here in a minute. So there's one box. And then here's the other. This is the top branch, and this is the bottom branch. Of course, everything ties into it there. So we'll close them up and get down off the roof and tie in down at the sub panel. Go ahead and tie them into the breakers down there, and the wiring will all be set. Only thing, the wiring will all be hooked up. Only thing required at this point, probably come back later this evening or early in the morning Monday, probably not tomorrow. Come back and finish putting the panels down. I think the panels will go down pretty quick. Then get it inspected, and it's ready for permission for Mon Power to commission it and turn it on. So next time I'll show you a video of the panels going down. Well, this is what everything looks like on the bottom side now. This is the sub panel box with the 2 branch circuits tied in up top. The one on the right, that's the upper. Second one's the lower. Third one you see there, you can see the wires coiled up down below it. That's the pre-wiring I did for the pergola. The future panels that's going to go on the pergola. No need to wire them up now. But You can see how we got two of the two neutrals tied in there, and then here's your L1 and L2 for your upper and lower circuit there. And all your grounds are down there, grounding block. And it goes back in there is number 4. You can see the number 6 copper coming right into the block, and then the number 4 bare copper is coming out. And that number 4 goes down to grounding rod. So that's what it looks like, all wired up. Okay, we've started panel installation, and you can see we're about halfway done with it. The panels are going down pretty quick. Once I got everything, all the slow work, everything mounted, leveled, everything underneath, it's kind of like I thought. Once you get to the point where you're putting the panels down, they just go down pretty quick. 4 attachment points on each panel. The mid clamps or the grounding clamps, they ground and bond everything to the rails. That's about it. I'm torquing them about 10 foot-pounds. It says to torque them, the mid clamps are 84 inch-pounds, the end clamps are 65, which that's about 5.5 and 7 foot-pounds. I found that, I don't know, that just didn't seem like that was much torque to me, so I'm putting 10 on them. Make sure them mid clamps got the teeth on them, make sure they really dig in, because I want a good ground on that for potential lightning protection, though I hope I never have to have it. But you never know. So that's it. I'll show you the finished product here when we get done, and then probably just show the meter or something when I flip it on. Show the commissioning process to turn it on and start it up. Alright, it's done. I stayed at it for an hour or two putting the last set of panels on across the bottom there. So that's pretty much the finished product. I'm going to call that inspector, have that state inspector, fire marshal inspector, he's supposed to come out and look at this and certify it, and then I got to send a certification paper in along with an interconnection agreement to Mon Power, and they'll either reply me by email or call me or something and let me know that everything's okay and I can turn it on. And then they'll bring out a net meter, digital net meter probably, and they'll install that, and that'll measure anything I export, or it measures how much I import and how much I export from my own system. So next time should be I'll shoot a short video of the system being energized and show you the meters, see what it does, and then that'll be it. Thanks for watching. Okay, we've turned it on. It's almost 10 a.m. so the panels have started to produce, and you can see actually we've done a little bit previously doing some testing, so it's ran a day or two just to see what would happen, but you can see that meter spinning. It's moving along at a pretty good clip right now because the sun's out. The sun's coming over the trees and hitting most of the panels now, so it's moving along pretty good. And you can see the consumer meter here. See how it's spinning in the opposite direction? It's spinning almost as fast in the opposite direction as my solar generation meter is spinning in the forward direction, in the production direction. I don't know if you can see a comparison of both of them here, but if you look down at the other one and then you look at this one, you can see this one's spinning. This one appears to be spinning faster in reverse than the solar generation meter is spinning in forward gear. It's probably because the house is using some of the electric off the solar, and it's it's still able to spin this one at a fair clip backwards. But you might be able to, you probably can't hear it, but the pool pump is running behind me. And the pool pump's taking a little bit off of it. There's not a whole lot running in the house. The air conditioner's not on now. The dryer, I don't believe, is on. But you can see the difference in how much it's making with the sun out. With the sun out, that is. It's going pretty good with the sun out. It's going real good with the sun out. So there it is. It does work. Okay, it's been a while since I shot the last video just showing the commissioning when I turned it on, and everything was fired up then, but and it worked, and I've been kind of monitoring it the last couple months. It's now October 31st, believe it or not. What you see right there in this camera shot, that's a net meter that the power company installed back in August. Since the last video, this was put in. Like I said, I've been monitoring it, and what this is a special meter, and what it does is, see if I can turn the brightness up here a little bit so I can see it myself. What it does is it measures a code 40 is an import from the grid, and code 04 is import from the grid, and code 40 is an export back to the grid. Now you can see that little arrow right there. Currently it's a cloudy day, so when that arrow is going, and it's going very slow to the right, that means we're pulling electricity from the grid. So we're importing now from the grid. Now if that arrow starts pointing this way, that means we're actually supplying the energy needs of the house, and we're exporting what's left over back out to the power grid. It just so happens this morning it's just cloudy. As we get on into later into the fall, we're having some more cloudy days, which that was one of the things I've been watching, is how the system performs when we get lower amounts of daylight hours and sunshine, which this weekend we're turning the clocks back, so it's not really going to affect it as far as how that works. It's just changing the time, but the hours and the daylight hours are getting shorter now, so it is affecting how much it produces in a day. But I just wanted to show you that meter right there, just so you can see what the actual net meter looks like. Okay, now inside, this is what we have inside. I have the panel, the covering off of the service panel, and this just shows, you can see how the wiring comes in. I don't think I've ever shown a shot of this, but the red, you can see the red, black, the L1, L2, and the ground, the neutral. See, they all come in here, and this is where they hook in down here to this 30 amp breaker. And by the way, I did change some things in the video from when I first started. I was going to put 16 panels on the front of the house. I have changed that, and you probably noticed that partway through the video. Now I'm going to do 8 panels on the rear pergola. I'm going to keep everything on the back side of the house. But this right here is all part of that. This is a 30 amp breaker. It was 50 originally, but it's 30 now. Now whenever I put the 8 additional panels on, that'll end up being probably a 40 amp. Because I'm not doing 16 panels, I'm doing 8 panels, if that makes any sense. But this here, you can actually see, if you look at it, I can put this clamp meter on, you can see it's pulling 3.8 amps off the solar panels on the roof, on each leg. 3.6, about the same. And what that means is it's pulling, it's generating electric, and it's back feeding it up through the main, and the L1 and L2 that's going, back to the grid. The main input here. Let's see if I can measure these. Push hold. See what we got. No, I didn't get it. Hang on. Take the hold off. Okay, this little clamp meter is just measuring the current flow, be it coming in or going out, importing or exporting. It's just measuring the current flow. Okay, we're getting 2.8 out of the L1. Let's see what we get out of the L2 here. Okay, we're getting 1.3. So 2.8 and 1.3. Of course, down here we're having 3.5, 3.6 coming in. So what that means is we got current flow coming in, feeding up through. Now the house is using some of this for all the lighting and everything. The house is using some, and I would say because it's a cloudy day and we were just outside and the meter was showing that we were importing from the grid, what you're seeing here, you're seeing, we're showing 0 there. Okay, the 2.8 you're seeing here on each side, it's going to vary a little bit, but what you're seeing there, that chances are that's probably being imported. That's 2.8 amps being imported. We're making 3.6, we're importing 2.8. So, you know, this would probably be somewhere around 5 or 6 amps coming in. If we didn't have this, we'd have about, each leg we'd be bringing in about 5, 6 amps. Instead, we're down to 1, 2 amps because we're making a small amount. So that's just equates to savings. So just thought I'd show you that. Hopefully that's not too confusing, but it's pretty neat to be able to, you know, you can actually see the current flow. So it's kind of handy to have a clamp meter to do that. I can show you here. This is probably what you want to see here to end this thing, because I'm not the best at editing, so I'm just showing you a whole lot of stuff here that's probably getting very long. These are all the receipts I have for the system. Lowe's places. There's local places I'm not going to mention, you know, the names since it's on YouTube. But eBay. This is the small, the safety disconnect, the small one I got. I think it's about $50 or something like that. Couldn't really find that at any of the stores around here, and the electrical supply companies, they didn't have one that small, so I ended up having to get it off eBay. So you can find just about everything on eBay. Different things that I bought, little pieces that, you know, that go up top. The water, the terminator caps, stuff like that. This is the Envoy. This is for monitoring. I got it for $375. The retail on that's about $5, maybe a little over. But I found one on eBay for that. And what that is that's that thing right there. That's the Envoy, and that thing plugs in, and it basically reads off your neutral. That's how it knows what each panel's producing. That goes to a website called Enlighten, and then you can monitor all this online, which my system is public, and you can actually see it online at Enphase, enlighten.enphase.com, I think is what it is. So back to the rest of this. Well, that was my watt hour meter I bought from Knowles Electric Meters off of eBay. That's their name. It was $20, so that wasn't too bad. Here's the bulk of it right here. A company called Henry Steig out of Boca Raton, Florida. Henry's Solar Sales. He's an independent rep for Allied Building Products. They have a warehouse up in outside of New York. I think it's just over in Jersey, and all this stuff came from there. It was shipped down via Conway Express, Freight Express. But you can see all this is the panels, the microinverters. Of course that's the most you're going to pay for everything, and then the rest of it's all racking. It's all aluminum, stainless racking. But all of that, bottom line, came out to around 12 grand. And a grand total, I added up all those receipts on the front pages, 13,055, just a little over 13 grand for this whole system. Of course, I did all the labor myself, but that's what all this system costs. So it's about 12 grand for the main stuff, and then all the electrical, the wiring, some stuff I found on eBay was another $1,000. So I saved myself some money putting all this in for what I have, a 6.6 kilowatt system. That's a pretty good system for the money. It seems like a lot of money up front, but I'll get 30% back federal taxes on that. So somewhere around 4,500, something like that. And then I estimate with some of the savings calculations I've done, probably within 6 years, the system will totally pay for itself. And then from there, hopefully, barring no unfortunate circumstances, about 25 years of virtually free electric. But I plan to add on anyway. I've wired it, as you've seen in the previous videos, to add on to it anyhow. So I'm gonna add on to it to credit myself even more, because I think this is going to come in somewhere around 80-90% of the household needs for the year, maybe 90%. It'll take about a year to really see it. But adding the extra 8 panels, I plan to cover that pergola in the back, basically make it a solar covered pergola. That's what Christy and I wanted to do. That should just push it clear over the edge, and pretty much the whole house should be covered as far as electric. And of course down the road, I'm thinking of things like a total electric vehicle, rather than fill up gas. My house is the gas station, so we'll do something like that. But anyway, that's it. So if you're interested in doing something like this, good luck on your project, and just so you can see how one person did it. My way is definitely not the only way. It's probably not the best way. But there's several videos out there, but I tried to put together just as much information as I went on this project as I could for others that may be interested in doing it. So in the future, good luck if that's what you're going to do, and I wish you all the best. Thanks, YouTube, and take care.